Okay, so we're starting our first and new unit in grade 11, and then we're going to start by modeling quadratic relations. The word quadratic means, anyway, quad means 4, but quadratic means to the power of 2. Okay, so anything to the, if your highest exponent is to the power of 2, right, that's quadratic. Okay, that is. Don't write this, I'm going to erase them. This is quadratic, right? Because your highest exponent is 2, right? If you have something that looks like this, that's also quadratic because when I expand, it's going to become to the power of 2. So this means quadratic. And the shape of quadratic has a parabola shape. So the shape of it would be like a U shape, right? Graph, or it would flip down, so it would be a U upside down. So it's called, this is called parabola. So it could be either up or down. Okay? Parabola.
Parabola.
Yeah. So you know how linear function have a straight line? Quadratic function has a parabola shape. There's a lot of characteristics of the parabola shape. Okay, I think that's what I want to do before I start medicine. I want to go over a few things. We're going to recover them. We're going to go over them, and I'll be very, very slow when I do that because I know if you haven't taken the grade 10 recently, you're not going to even remember any of this. So why don't we start with introducing the problem? Okay, so if I have this is a parabola shape. It's very bad drawing, but that's the best I guess. Okay, so if you look at this, actually let me draw another one because I really don't like this one. Doesn't look good. Anyway, so the characteristics of a parabola number 1, that it's symmetrical. Do you guys know what a symmetrical means? What's symmetry?
Same on both sides?
Same on both sides. That's right. So our face, they say they're not symmetrical because we're not perfect, right? But if you think, just pretend that it is, right? If I actually draw a line right here in the middle of my face, right? If I go to the right and to the left, I have the same distance, hopefully, from the symmetrical line, right? To my eyes, to my eyebrows, to half of my mouth, right? It's shaped the same, and so on and so forth, right? If you have, let's say, a butterfly, I can't draw, but if you have a butterfly, right, and you cut that butterfly in half, like this, it will be symmetrical, because if you actually fold it on top of each other, they're gonna fold perfectly, right? If you have a sheet of paper, and then you perfectly fold it on top of each other, right, in the middle, these are symmetrical, okay? And that line right here, if I can draw that, a line right there where I just folded it, we call that line a line of symmetry, okay? So that's when you fold your paper, it's gonna fold symmetrically. Are we okay with this? All right. So quadratic function has symmetry. Now it doesn't look like it here because I can't draw, but it's just the way this draws, right? So technically there is a line of symmetry, and the line of symmetry will be right in the middle. Right there. Okay, so technically if you actually look at a good parabola, if you draw a line right in the middle that passes through that point, that line is called an axis of symmetry. Okay?
So you're basically dividing the parabola in half.
That's right. All right? And the axis of symmetry, yep.
On the second page,
Yep.
or
That's a
the
homework
first
booklet,
one,
right?
the example F, can the x-axis be construed as the line of symmetry?
The line of symmetry is always vertical in this case. In the case of parabola, the axis of symmetry is always vertical. Yes, I know what you mean because that's a sideways parabola, then the x-axis is your line of symmetry in this case, that's right. But this is not considered a parabola. This is a sideways parabola, which doesn't make it a quadratic, okay? All right, now, other than the axis of symmetry, we have the zeros, or the x-intercepts, okay? Where would you think the x-intercepts are? So these ones? Yes, that's right. So these two lines, where the graph is intersecting the x-axis, these 2 points are called the x-intercepts, or they're also called zeros, right? There's too many names for them, the x-intercept, zeros, roots, solution, yep.
So in that example that I showed there, they are the y-intercepts?
Yes, in that case, there are the y-intercepts. Okay? So these are your x-intercepts right here. A parabola can have either, the maximum it can have is 2 x-intercepts. Okay? You can't have more than 2 x-intercepts. But we have also some situation where we have only 1 x-intercept. Okay? We also have some situation where we have no x-intercepts. Okay? So you can have these 3 different scenarios: 2 x-intercept, 1 x-intercept, or no x-intercept. The point right here, we call that point the y-intercept, because that's the one that intersects the y-axis. And one of the most important points on the parabola is called the vertex. The vertex is your point where your direction is changed. Okay, so as you can see here, the parabola was going down until it reached that point, and then it flips and then go back up.
Is it called something different when it goes down, or that's probably a different situation?
It's called the vertex, but it can be either a max or a min. Okay, so in this case, I have a minimum, right? Because you're going down to a lowest point, and then you're going back up. So this is going to be your minimum point. All right, so look at this. So it's called the vertex. A vertex is a point, so it will have x and y values. Okay? And in this case, it's a minimum. So this is opening up, right? When the graph is opening up, you have a minimum. You can see that right there. When the graph is opening up, you have a minimum. Okay? In the cases that your graph is opening down, right? Your vertex is gonna be a max. Are we okay with this so far? Are we okay with this? Okay, so the axis of symmetry is the line that cuts your graph vertically in half. It passes through the vertex, as you guys can see, right? It passes through the vertex. You have the x-intercept. You can have 2 of them, 1 of them, or none. And you also have the y-intercept. And we have the vertex, which is either minimum or max. Okay? I'm gonna, before we move on, I'm just gonna go and graph the parent of all quadratic functions. So all quadratic functions come from one parent, and that parent will be moved left, right, up, down, vertically stretched, vertically compressed to get all the other quadratics from it. Okay? So the parent of all quadratics is y equals x squared. Okay? So this is the origin of quadratic. This x squared, it's not moved, it's the basic of everything. Okay? Anything I add or subtract or multiply to x squared, so the minute that I have like x squared plus 5, still quadratic, still a parabola, but it's a moved parabola. It's a transformed parabola. It's a different version of the parent. Do we understand what I'm trying to say here? So let's look at the parent.
So at y equals x squared is the basis,
Of
like the original copy.
It's the original copy. It's the first copy. It's the 1.0 copy. Okay? Not transform. So everything that we compare, all the other quadratic that we compare, we always compare them to this. You're going to see what I'm talking about, because later on we're going to talk about transformations. Okay? So when you have this parabola, let's say, right? Let's say we have this parabola, right? They're going to ask you, how has this parabola been transformed from the original parabola, from this original? So we always compare all the parabolas to the original. Okay? You'll see it in the next lesson. Okay? So let's first look, how does the original parabola look like? So let's do a table of values. So a table of value, you usually pick values for x. So we're going to pick values of negative 2, negative 1, 0, 1, and 2. These are points that you pick, x values that you pick. Okay? Let's find the y values. What do I do? So what do I do?
Y equals
Minus 2 squared.
Negative 2 brackets squared, right? So I replace the x value with a negative 2. Right? Okay, so what's negative 2 squared?
negative 4.
Positive. Because negative 2 times negative 2 is
Positive.
positive. Negative 1 squared?
Positive 2.
No.
Positive
right?
1.
Negative, it's positive 1. Because negative 1 times negative 1 is 1. How about 0 squared? How about 1 squared? How about 2 squared? Okay?
Where did you get this x values?
You just picked it. I picked them for you. Okay? Okay, let's plot this. So,
Doesn't apply to you, does it?
negative 2,
The purple one, it doesn't apply to you.
negative 2, and 4. So negative 2 is right here, and 4 is right here. Negative 1, 1. Then I have 0, 0. 1, 1. And and 2, 4. So I'm gonna join these points together. What shape do I have? Parabola shape. Right? So this is the origin of all parabolas. Why? When you see the y equals x squared, this is what you're going to have all the time, just y equals x squared by itself. Anything that you change, right, then this graph is going to be changed. Either it's going to be moved upward, or it's going to be moved downward, or it's going to move to the left, it's going to move to the right, it's going to do too many different things at the same time sometimes. Let's see. What can you tell me about this y equals x squared? So what is the axis of symmetry? Where would it be?
The axis of symmetry.
In the 0.
On the 0 line. So at x equals 0. So right here in the middle, right?
Yeah.
Right? So at x equals 0. Good. Where is your x-intercepts? How many do you have? How many x-intercepts do you have? Only one, which is at what?
0.
0, 0, right? You're only intersecting the x-axis once. Good. At 0, 0. What's your y-intercept? Again, at 0, 0. Again, it's intersecting the y-axis right here, right? So that's why it's original. That's why it's different.
It's what? I didn't hear the word you used. It's what?
Original.
Sorry, I was chewing my nose.
Okay? So the x-intercept is at 0, 0. The y-intercept is at 0, 0. The vertex is at 0, 0. Okay? So this is the origin of all the quadratic functions.
This is how you know by checking that, right?
Well, this is, yeah, but then you can also have that, but with, like if you have this, let's say, I don't want to if you have this, right, that's a different version of it. It still passes through the 0, 0, but it's a different version. So this is when you have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. This is the original of quadratics. Okay, so now you know quadratic should have a degree of 2. Highest degree is going to be 2. And you know that the shape of it is parabola. Okay? Now let's go back to our lesson and let's see what shapes we have and what kind of functions.
Excuse me.
Yep.
I see some people are writing their like examples that might help them, and they're writing it on a blank sheet of paper. Are
Yeah.
they able to use that with this?
This is
or
the
do you wanna
homework,
write
right?
on it?
This is the homework. Yeah, that's fine if you write all of it. I'm okay with it,
Like
right?
the stuff that you're
Yeah.
tutoring us, we take notes. Are we allowed to
Sure.
write it on here?
Sure. Okay. Now we're gonna use the notes booklet to fill out the notes. Okay? Alright. So complete the chart below and then graph. So the distance traveled by a boy on a bike is modeled by the equation y equals 3x. Okay? So this is my equation. And I have to fill out a table of values, and then I have to do what we call the first difference and the second difference. I'll explain these to you. And then I have to graph. Okay? So to fill out the table of value, usually they will give you the x values, and then you have to fill out the y values. This is already filled out for us. Okay? So what we have to do is we have to replace the x with whatever x values they give us. Okay? So in the first case, I have 3 times 0, right? Because my x is 0. 3 times 0 gives me 0. For the second case, I have 3 times 1, right? Because my x value is 1. So it's going to be 3. X is 2, so 3 times 2 is 6. X is 3, 3 times 3 is 9. X is 4, 3 times 4 is 12. Are we okay with this? So these are my x values, and these are my y values. Okay? When I graph x and y, right? So when you put it on the x and y axis on the coordinates, right? You're gonna put x and y as 1 point, x and y as 1 point, and so on and so on. Okay?
Yeah.
Now, what does the first difference mean? Who knows what first difference represents? What does the word difference mean?
Isn't the first difference if your things are all the same in one column?
If when you do the first difference and you get them constant, that means sum. But what does the word first difference? What does difference? What does the word
Not the
difference mean?
same. Not.
They're not the same, but in math, what does difference mean? When I say I'm finding the difference between 10 and 12, what's the difference?
Subtraction.
Subtraction. Okay? So when we're doing the first difference, that means we are subtracting our y values. Okay? So the first difference and second difference are done for testing. So you do the first difference to see if your equation is linear, and you do the second difference to see if your equation is quadratic. Okay? You're going to see what I mean by that. So look at this. These are my y values, correct?
Yes.
So what I have to do, eyes on the board for a minute, please. What I have to do is I have to do the first difference. So I have to start from the bottom y, and I have to subtract 3, take away 0. Right? So I'm subtracting my y values. I start from the lower one, so 3 take away 0, that gives me 3. Are we okay with that? Then, well, after I've done this, I'm going to have to take the lower y value and subtract it from the one right on top of it. So 6 minus 3 is 3. 9 minus 6 is 3. 12 minus 9 is 3. So what you see here is that the first difference is constant. Constant means the same. So if you look right here, the first difference for all the answers is 3. So that tells me that it's a linear function. Okay? So, first difference is constant. Therefore, it's a linear function. Now the question would be, what if the first difference is not constant? Then we have to move to the second difference to test it. Okay? But we'll see examples like that. So right away, if you get first difference constant, you stop and you say that it's a linear function. Do you all understand that?
That's our final answer for that.
This will be your final answer. So what we're going to be doing here, we're going to learn how to be able to identify a linear function using 3 different things. We're going to be able to identify a linear function by looking at the equation. How do I know that this is linear? Degree of linear. Degree 1. So a linear function because it has a degree 1. Okay? So if I look at the equation, I know it's a linear because it's a degree 1. Who doesn't understand that?
Me.
Okay.
I don't understand.
Okay. So when you are giving an equation and the question asks you, determine if this function is linear, quadratic, or neither. This would be the question. Okay? So you're given this. All what you have to do, look at the x and then see if the exponent for the x is 1, 2, or anything else. If the exponent on the x is 1, or there's no exponent, then it's a linear function. Because remember that a linear function is mx plus b, right? X doesn't have any exponent on it. Are we okay with this?
Yes.
Now, if your function is like this, let's say, and looking at the function, what is my highest degree there?
2.
2. So what do I say? Is it linear?
No.
It's quadratic. Now what if I have something that looks like this? It's neither, right? Because what's your highest exponent?
3.
3. So we call this neither. There is a name for it, right? But for the purpose of this course, this is called neither. Okay? Anything other than 1 and 2, we're going to call it neither in this course. Up to now. We're going to learn something new later on.
So it's
Okay.
not cubed?
It is cubed, but we don't call it cubed because we don't, the question would be asking you, is it linear, quadratic, or neither? So you have to pick the neither because it's not linear, it's not quadratic. Okay? So, when I'm given an equation, I look at the degree and I decide. We all understand that? Okay. If I'm giving a table of value, I have to do my first difference. If my first difference is constant, that it's linear. And I stop. And I say it's linear because the first constant, the first difference is constant. This is my therefore statement. Now, let's graph this. Alright, so my first point is 0, 0. Always label your axis. I should do that more often for you guys. I don't want to see graphs on the test with no numbers on them. Okay, my second point is 1, 3. Two, 6. 3, 9. I might not be able to fit this perfectly, but I'll try. As you can see, my line is not perfect because I can't. Ooh.
Your graph isn't perfect.
Because my graph is not perfect. Yeah. And because of this, these are not perfect, right? So everything, and I can't locate it properly. So
Are we going to get your graph paper for this?
you can use graph papers. I'll usually give you a grid, which is like it will be a graph on there, so you can use that. Okay. What can you tell me about this line? About this function? It's a linear function. It's a straight line, right? So if you're given a graph, if you are given a graph and the graph is a line, you can say it's a linear function because it's a straight line. Are you guys okay with this so far? Okay, so we looked at an equation, we looked at the table of values, and we looked at a graph. So what you're gonna do right now, you're gonna fill out, this table is like partially filled out for you. So they already gave you the equation, right? They've already plugged in the values for x for you, so you just have to find the value of y and do the first difference. Okay? You're gonna say the same thing in every single every single place, right? So you're gonna have to tell me if it's linear and why is it linear. You're gonna have to tell me if it's linear and why is it linear. And then when you graph it, you have to tell me if it's linear and why. Okay? So exactly the same thing I did above, you're gonna have to do here.